Alright, grade 12s, now that we've done our first video on the introduction to circles, this video is just going to look at some slightly more complicated questions. So, first example says, determine the equations of these circles, so it could be one or two of them, which has a radius of 5 and it passes through the points 2, 0 and 8, 0. So first of all, I always start with what the formula is. So it's x minus a squared plus y minus b squared equals r squared. Now we're quite lucky here and we have r. So immediately what I'm going to go and do is put in my 5 squared, which is actually 25. Now that leaves me with multiple unknowns. So for example, I don't know a and I don't know b. So those are two unknowns. However, I do have 2 points. So I'm starting to think that this could possibly be a simultaneous equation. Now this looks like a really horrible simultaneous equation, but what you're going to soon realize is that these things actually simplify really nicely. So I'm going to sub in the point 2, 0 and see where I get to. So x is 2, so this would be 2 minus a squared when y is 0. So this is 0 minus b squared. Now this is equation number 1. I'm going to simplify that a bit, so I'm just going to square this out. So this is 4 minus 4a plus a squared plus b squared is 25. Now what I'm going to do is I'm going to sub in the next point, which is 8, 0. So I'm going to write, and if we had 8 minus a squared and 0 minus b squared, that must also be 25. So if I multiply that out, I get 64 minus 16a plus a squared plus b squared, which is 25. And that is equation number 2. Now if we approach this from a traditional approach of isolate one of the letters and then substitute, this can get quite messy. However, let's have a look at this. This first equation equals 25. The second equation equals 25. So can we not equate the fact that these two messes must be equal to each other? Because they're both equal to 25. Now, you might initially balk at that idea because you might think, oh, but then there's still A's and B's. But what's beautiful about this particular example, it doesn't necessarily happen in all examples. And so we'll do an example which is slightly different. But what you will notice here is that the only thing that involves a b is the b squared. Now I have a b squared on this side and I have a b squared on that side. And so they're basically just going to cancel away. I also have an a squared on this side and an a squared on that side. So they will disappear. So basically I land up with 4 minus 4a equals 64 minus 16a. So I land up with a really easy equation. Now this worked out really nicely because I didn't have b's as well. So the key to this working nicely was the fact that this was 0 meant that in both equations I just landed up with b squareds. There weren't other b's, and so my b's actually could disappear. So if I just solve this now, I get 12a equals 60, which means a equals 5. Now that a is 5, I need to find b. Now, in order to find b, I'm either going to go to this equation here and substitute an a, or this equation. It doesn't really matter. So I'm going to go to equation 1. So equation 1, I actually would prefer to maybe go back to the original, simply because then I don't have to substitute in a too many times. So if I go back to the original, this is 2 minus 5 squared plus b squared will be 25. Now, this will be negative 3 squared, which is 9, plus b squared is 25. So I'm going to get b squared equals 16. Now, sorry, I've run out of space here. Very importantly, why did it say equations of the possible circles? Whenever they say that, I always take that as a hint is that there's possibly 2, and there's probably 2. The reason why they did this is if you square root 16, you get plus or minus 4, not only 4. So it is actually possible that there's 2 different circles here happening. Now, r has to be positive, but no one said that b has to be positive. So therefore, what are my 2 possible equations? It's definitely x minus 5 because my a is 5, but in my b value can either be negative 4, in which case I'll have plus 4, or exact the same center value for a, but you could have a y value of positive 4, in which case this would be minus 4. And so those are the 2 possible circles that could occur. Right, really nice question. Let's look at another one. Determine the equation of the circle has a diameter of CD and they've given you the coordinates. Now, if I'm really struggling, I draw myself a picture. We never draw too accurately, but 2, -1, let's pretend it's about there. So this is 2, -1, and D is at -6, 7. So D is somewhere around there, -6, 7. And this is probably not going to be my best circle, but anyway. There we go, there's a circle. And that, oh, terrible looking circle, because that does not look like a diameter. So let me try again, for the sake of making it look a little bit believable. Again, terrible. Anyway, it will work. Now, what do we know about a diameter? Well, a diameter goes straight through the center. So I know that the center of the circle must be, and I'm going to call it M, and I'm going to call it M because it must be the midpoint, because the radius would be half of the circle, so the center will be in the middle of the diameter. So my midpoint I can calculate really easily. You don't actually have to show any working in calculating a midpoint, but for the sake of notes, you add the two x values together and divide by 2, add the two y values together and divide by 2. So my midpoint, which is my center of my circle, has a center of -2 and 3. Now that's really great. So it's given me the center. I don't have my radius. So let me write down what I have so far. So far I know my circle is x plus 2. Don't forget that it's minus minus, so it becomes a plus. And this is y minus 3 squared equals r squared. So the only thing I don't know is r squared. Now, when I first thought of doing this, I thought of finding the distance between C and D, because that would be the distance of my diameter. And then I'd halve it to get my radius, and then I can square it to get r squared. Now it's a little bit of work. It would be the distance formula and then halving and squaring, not a problem. But now that I've just written down this formula, I'm like, hang on, if I have the formula and I have a point which is on the circle, why bother going to find the diameter and doing it the long way? Can't I just sub in C? So if I sub in C, I will get 2 plus 2 squared plus -1 minus 3 squared equals r squared. Now, really important just to mention here, you've got to remember that you can only substitute in points on the circle. So you can never substitute in a point in the circle, for example, the center. It must be on the circumference. Now, I would use my calculator and I get 32 is r squared. Now, remember, we don't bother finding r because my formula has r squared in it. So there's no point in square rooting. I can just go straight to the equation of my circle. So the equation of my circle is x plus 2 squared plus y minus 3 squared equals 32. You could have done the distance route, and there's nothing wrong with that. Try to always pause and think before rushing into a question, because it's useful to save time in the easier questions. So pause and think of what the easiest way is. Also notice I only realized that this was an easy method for me to do because I wrote down what I know so far. So often it also helps to just pause and write down what you know so far before you launch into the next step. Right, so now we move on to what I would classify as a really complex question. And I would classify this as a very mean question. It's not one I'd particularly ask in an exam, but it's very nice to see. So it says determine the equation of the circle passing through, and it gives us 3 points, -1, 0, 2, 1, and 3, -2. Now the problem is, I don't know whether those are diameters, they're just random points on the circle. Now, there are 3 unknowns in any circle, because any circle is x minus a, so you need to know a, and it's y minus b, so you need to know b, and you need to know r. So 3 unknowns, 3 points. This is sounding very much like a simultaneous equation. Now it's a fairly mean simultaneous equation because we've never done one like it. But there's no time like the present to try something new. So if I substitute in -1, 0, I'll get -1 minus a squared plus, and this will be 0 minus b squared is r squared. So if I multiply out, just to get that into a decent looking equation, this is 1 plus 2a plus a squared plus b squared is equal to r squared. So this is equation number 1. If I move on to my second point, equation number 2, I'm actually going to do it next door. Equation number 2 would be 2 minus a squared plus 1 minus b squared equals r squared. So if I neaten that up again, so this is 4 minus 4a plus a squared plus 1 minus 2b plus b squared is r squared. Okay, now if I just neaten that up a little bit, that's a squared minus 4a, and then there's a b squared minus 2b, and my constants are 4 plus 1 is 5. So plus 5 is equal to r squared, and this is equation number 2. Now, at the moment I have 2 equations, but I have 3 unknowns. I can start working with these in order to find me another equation. It's quite weird without actually just starting. So let's just start. You'll notice, like we did in the first example, here's an r squared and here's an r squared. So what I'm going to do is I'm going to equate these two to each other. So I know that the r squareds must be equal to each other. So 1 plus 2a plus a squared, let me erase this, plus a squared plus b squared is going to equal a squared minus 4a plus b squared minus 2b plus 5. Now you'll notice in example 1 the b squareds cancel and I just had an equation with a, whereas I don't have that here because the b's are there as well. However, this can simplify down quite nicely because you'll notice I have b squared and b squared, so they will disappear. I have a squared and a squared, so they will disappear. So if I just make this, I'm going to hop these a's across, so I'm going to get 6a, and if I'm going to have minus 2b on this side, and then if I shove that 1 over, I'm going to get plus 6. Now as I said that, I realize I'm not going to have plus 6 because 5 take away 1 is plus 4, so that's a bit better. Now this is an equation involving a and b. Now I can't solve for a and I can't solve for b because it's just one equation. However, if we now go substitute in point 3 and we use either equation 1 or equation 2, we can create another equation involving a and b, and then we can solve them simultaneously. So from point number 3, let's go substitute it in. So this is 3 minus a squared plus negative 2 minus b squared is r squared. So this is 9 minus 6a plus a squared plus 4 plus 4b plus b squared equals r squared. I can possibly neaten it up, but it doesn't really matter. This is equation number 3. Now if I look at the first 2 equations, I would say the easiest of these equations is this one over there, simply because it didn't have lots of b's, etc. So basically I'm now going to say, can I not equate these two? These are both equal to r squared, so can I not equate equation 1 and equation 3? So that means that 1 plus 2a plus a squared plus b squared is going to equal to 9 minus 6a plus a squared plus 4 plus 4b plus b squared. Now again we can neaten this up. I have a b squared and a b squared, and so they will disappear, and I have an a squared and an a squared, so they will disappear. And this is the beauty of circles. The a squareds and b squareds always cancel, so it's never as threatening as it looks. Now again, if I get all my a's to one side, so I'm going to get 8a to this side, I'm going to have 4b over here, so that's my b's done, and if I kick across my 1, my constants are 9 plus 4, which is 13, minus 1 is 12. And so here is my second equation, simplified equation I should say, between a and b. Now I suppose the question is, what's the easiest way to solve these two? Now the long way to solve these two would be to pick one of them, isolate the letter, substitute it in and solve. So I would probably take this first equation here, I'd probably isolate b, because dividing by 2 is something I could do. I would then substitute it into my equation and solve for a, solve for b. However, is there a faster way? Now there is a faster way, because don't forget that you're allowed to add and subtract equations from each other. So personally, I would take this equation here and I would multiply everything by 2. So if I multiply by 2, what equation do I get? I get that 12a is equal to minus 4b plus 8. Now why do I do that? Well, because if I write that underneath here, 12a equals minus 4b plus 8, we know that you're allowed to add and subtract an entire equation from each other. So what works here is that 8a plus 12a is 20a, 4b minus 4b disappears, 12 plus 8 is 20. And so I get a is equal to 1. And you absolutely could have done that the longer way. You could have isolated b, substituted in, solved for b. I just like this elimination method. Okay, now we have to solve for b. I would probably use this equation now to solve for b, because I know that 6 is equal to negative 2b plus 4. So I'm going to minus 4 on both sides. I get 2. 2 is equal to negative 2b, and b is equal to minus 1. Now that means we're almost there. However, I just have to find r squared. So I would go back to my first equation. So my equation over here, this one right at the top here, or any of these equations that you substituted a point into. So I'm sorry, I'm running short of space here. But basically I now know that negative 1 minus a squared plus 0 minus b squared, so it's actually plus 1 squared, is r squared. So I get an r squared of 5. So apologies for being quite cramped and all over the place here. But finally, this means I have my equation of my circle. So my circle is x, and a is 1, so it's minus 1 squared. B is negative 1, so it's actually is plus 1 squared, and that equals to 5. Now let me just say this again. Personally, I would never ask this in an exam, simply because it's just too much working. This is worth too many marks for me to be able to put it in an exam. However, it's always good to practice our skills, because you never know what type of question might use this kind of idea of where you can do like kind of like rolling simultaneous equations. Plus it was just fun, wasn't it? Right, so last example is a fairly common question. So this is definitely very, very common. The equation of the circle, and it's given to you. Now we have practiced the idea of rewriting that in standard form by completing the square. It tells me it has a radius of 7. Determine the value of k. Now really importantly, I need to be able to write this in standard form so I can see where the radius is. So if I just write this in a different way, I don't know what happened there, let me try that again. If I just write this with my x's first, so x squared minus 4x first, then my y squared plus 6y. Now I'm going to kick over the k, which becomes minus k to the other side, because that's got nothing to do with my x and y values. So now I'm going to complete the square. This would have come from x. I halve the coefficient of the x, so minus 2 squared. However, in doing that, that multiplies out to x squared minus 4x plus 4, which means I effectively just added 4 to the left-hand side of the equation, which means I need to add 4 to the right. Right, so I've added my minus k in there. Now to complete the square with this, I halve that coefficient of the y, which is 3, because it was positive 6, and squared. However, that would actually multiply to y squared plus 6y plus 9. So you've effectively added 9 to the left, which means you must add 9 to the right. So what is actually happening on this side is I get negative k plus 13. Now, however, this, whatever's on this side, this mess over here, has to equal to r squared. Now, I was told what r is. R is 7. So this mess is going to have to equal to 7 squared. So therefore negative k plus 13 has to be equal to 7 squared, which is 49. So if I minus 13 on both sides, I get 36. And if I divide by negative 1, I get negative 36. And so simply by rewriting this to getting standard form and being able to see what r squared has to look like, because I knew the value of r, I could equate it. I think the most important thing here is most people just equate it to 7 and they forget that it's r squared. So that mess is equal to 7 squared. Now this example 4, you'll probably see it about 10 times in the last couple of past papers. Very, very, very common question.